Welcome to another video from sickmaths.co.uk where you can find lots of free maths videos. This video is about important graphs that you need to know for your GCSE. I'm just going to outline these graphs. There are other videos about how to transform the graphs into slightly different types, so you just need to know the rough shapes here. This shape of the y equals x squared graph is a smiley face always, so just know that. Y equals x cubed is shaped like that, but more commonly than the pure y equals x cubed graph is the y equals x cubed plus something, which brings out its hump. So if you got x cubed plus 5x plus 2 or something, I don't know, it automatically brings out these little humps there, two of them. Then you've got your y equals sine x and your y equals cos x graph, okay? There is a y equals tan x graph in the syllabus, but I've never seen it in the exam papers, and probably the reason why it doesn't come out is because it's just a bit weird and a bit complicated. So yeah, let's just talk about this sine x graph. It starts with 0 at 0 degrees. Sine x equals 0, so it's there. You can use your calculator to check on these points. Like if I did sine 90, you'd get 1, etc., etc. But without a calculator, you can know what's happening in these graphs, because these graphs are based on right-angled triangles. Yeah, the ratio between, for example, the sine graph is the ratio between the opposite and the hypotenuse. So in this case, the y-axis tells you how tall the opposite is, and r, I just say, is your hypotenuse, right? And your angle here, which is using a strange symbol called theta, don't worry about that, it's just some symbol, it's just another letter, right? So if your angle, for example, is crazy like 90 degrees, I mean, you can't really draw a right angle triangle with two right angles, can you? But imagine that it was allowed, because it's mentioned in this graph anyway. When the angle here is 90 degrees, r is forced all the way up there. It's basically vertical, which means it's right next to its opposite, which is also going to be there. So the opposite and the hypotenuse are going to be the same length. Yeah, so it's like the hypotenuse has length y as well, so it becomes y divided by y, which is 1, which is why when you've got sine 90 degrees, yeah, it equals 1. And you can do similar explanations for all sorts of angles, even beyond 90 degrees, yeah? You can have a quick look at cos as well. Imagine we make another impossible triangle where this angle is 0 degrees, okay? So r is lying down now, okay? And cos is the adjacent over the hypotenuse, and in this case the adjacent is the x value, because whatever number we put there will be your x value, which is also the length of your adjacent. So anyway, you've got your r divided by your x, and again they're the same length, so you get basically x divided by x, which is 1 again. So when in the cos graph, when you've got 0 degrees, that also equals 1. So those are the strange kind of things happening that might... I really do like to explain things, though. For some people it might be confusing and too much information, but some people who really are interested and do want to do well, they'll use this and help them memorize what's happening in this graph. Anyway, let's move on to the equation of a circle. Okay, in GCSE they keep it nice and simple. The center of the circle is always at 0, 0. And all you need to know is what's the radius of this circle. Once you know that, you can write down the equation of a circle. In this case, the radius is 3. So all I write is x squared plus y squared equals 9, because all you put at the end is the radius squared. The equation of a circle does not look like other equations that start off with y equals y equals y equals. This equation is always x squared plus y squared equals the radius squared. Okay, so if the radius was 5, I'd write x squared plus y squared equals 25, because 5 squared is 25. Okay, now let's move on to the last graph. Okay, and it's got like a strange thing that it doesn't seem to touch the y-axis or the x-axis. It's kind of going sloping really close to the axes and then going close to the other axes. Okay, what's happening is that it doesn't ever touch these axes. It's got what you call an two asymptotes, one at the x-axis because it gets closer and closer to the x-axis but never reaches that, never touches it, and on the y-axis is the same thing. It gets closer and closer to the y-axis but never touches it, and the same is on this negative side as well. It gets closer and closer but never touches. And the reason is, if you think about some of the calculations you have to make, let's say, why does it not touch the y-axis? Okay, well, to touch the y-axis, x has to be 0, basically, doesn't it? Okay, but can you get a y value for x equals 0? If you put x equals 0, then you get 1 divided by 0, which is infinity. So where are you going to write infinity? You can't actually touch it. And the same is true the other way around. You know, if I put x as a really, really big value, or is there a value of y such that, is there a value of x that will make y equals 0? Yeah, 1 divided by what will make this equal to 0? And there is no such number. You can divide by a really, really, really big number, but you're never going to get to 0. Yeah, you can make it really, really small, like it gets smaller and smaller, but it never becomes 0. So that's all there is to know about it.